sorting, measuring, selecting, and filtering objects in the pipeline. Now that you've got a little bit of an idea of what the pipeline can do, we're going to spend some time in this nugget learning how to manipulate objects in the pipeline. We'll start by looking at how to sort objects that are in the pipeline, putting them in a different order than what they were. Then we'll look at measuring objects, selecting specific properties from an object, selecting a subset of the object, such as the first 10 or the last 10, filtering the objects, and finally we'll sort of take an introductory look at the workflow in Windows PowerShell. How you can type commands, try things, retype commands, try different things to come up with the exact command you need to perform whatever task it is you're trying to accomplish. Let's start by opening the shell and looking at some different ways of sorting objects. Now to get us started, let's just start with a basic command like getProcess. By default, it looks like this is sorting, alphabetically based on the process name. Well, what if that's not what we wanted? What if we wanted to see the biggest virtual memory user first? So we want to sort it on that VM column. Well, first of all, let's get a process object and pipe it to getMember. Remember, that has an alias of GM. And take a look at all the different properties we have to work with. We've got virtual memory size 64. So those are two properties that we could choose to sort on. We've also got some shortcut names for some of those. VM is a shortcut to the virtual memory size. So we could choose to sort it on the VM property. Doing that's really easy. Just get the objects, get process, and pipe them to sort object. Tell it the property, or properties if you want to provide a comma-separated list, that you want things sorted on. We'll just do VM. And now you can see that the processes are sorted in order of virtual memory. What if we wanted the top virtual memory users at the top? Oh, no problem. We would just hit up arrow to recall that command, and then type -descending. That's a parameter of sort object, and it'll change it so that the VM column is sorted in descending order, so that the largest virtual memory user, and it looks like it's Windows PowerShell right now, shows up at the top of the list. Now, of course, you don't have to type all of these commands in their full commandlet name. Instead of getProcess, we can use the alias PS. Instead of sort object, we can just use sort, provide the property name we want, and remember, you don't have to type the entire parameter name. I usually just use DESC. It's shorter, and it still kind of reminds me visually that this means descending. Hit enter and I get the exact same results. If you want to provide multiple different properties to sort on, you can. For example, here we see that we've got several different processes with the same name. If we just run getProcess, those all kind of stack up together because they're the same name. So let's run getProcess. Let's sort it on name first, which is the default. But within the name, let's sort it on VM. So you can see that the overall order is still the same. It's alphabetical based on the process's name. But once we get down to repeated process names like service host, it's sorted in order of virtual memory utilization. So you've got a lot of options to sort these however you want to. If we were working with services, for example, remember that's GSV as an alias, we might want to sort them on their status, so that the ones which are running and the ones which are stopped show up in a different order. Now here's something that may make you curious. Notice the status stopped comes before the status running. It seems kind of odd because the word stopped alphabetically comes after running. Well, what you're seeing is the fact that under the hood, Windows is actually representing this stopped as a digital value. It's a 0. And then running is 1. And that's why stopped shows up first, because 0 is less than 1. So it is sorting them in order. It's just when PowerShell goes to display this, it's translating that 0 and 1 value into stopped and running, more really for our benefit, since the 0 and the 1 wouldn't necessarily be as meaningful to us. So it's sorting it based on the underlying value, and then when it actually displays it, it's translating it. So lots of different ways that you can manipulate objects in the pipeline, and sorting is one of them. One of the other things we might want to do is measure some of the objects that are in the pipeline. Now there's a couple of ways to do this. I could start by typing getService and simply pipe them to a commandlet called measureObject. that measures the number of objects in the pipeline, 120. That means I have 120 services on the computer. Notice that it seems willing to tell me an average, a sum, a maximum, and a minimum, although it didn't fill that information in. Well, that's because if we just run get service, you see that we really don't have any numeric or types of data. There's no measurements here really. We can't get a maximum name, or we can't get an average of the display name. So another type of object we might want to look at then is get process, because this definitely has a lot of properties which contain numeric information. So let's pipe get process to measure object. Well, it still counted it, but it didn't fill in the average, the sum, the maximum, and the minimum. All right, maybe we're not using this correctly, so it's always good to turn to help. Never be afraid to read the documentation. Let's ask for help on measure object. Now I see that I have a property parameter where I can provide the name of a property, and I have parameters for average, sum, min, max. Now, so maybe I have to specify the ones I want to see. Interesting. Okay, let's actually ask for help again and see if there are some examples. And there are. So we can specify the name of a property and then specify the different measurements we want. So let's take a try at that. Let's pull that original command back up, specify the property physical memory, and ask it to give us the sum, min, max, and average. One of the things you'll notice is that in the documentation it says that the parameter name is minimum, maximum, and average spelled out. I'm able to just put min and max because those are enough characters to differentiate it. One thing I'll sometimes do though is I'll forget what I'm doing and I'll put AVG for average because that's kind of a common abbreviation, but that won't work. I could put AVE or even just AV, but I tend to actually just spell out average because it's kind of what I'm used to and it keeps me from messing myself up. Once I do that, I can see that I've got an average of about 65 megabytes, 249 megabytes total. The biggest process looks like it's using roughly 42 megabytes. The smallest is using 0, and as a reminder, the property that's being measured here is physical memory. Now here's something interesting. Let's go back to the help on measure object. Oops, measure object, not measure command. And you can see that I can specify these other things: line, word, character. So this is obviously providing some way of measuring text or text files maybe. Textual properties are measured when one or more of the line, word, or character parameters are specified. So let's try and use that. Get service, pipe to measure object. Let's measure the display name property, and let's see what all these do: line, word, and character. Looks like there are 120 lines, which makes sense because there are 120 services. There are a total of 384 words, 2,966 characters in the display name property for all of my services. I can definitely see where that might be useful to, for example, measure log file length, or measure the number of words in a particular document, perhaps compare it to another document. So definitely some good uses there for measure object. Now let's talk about something that you may have been wondering about. When you run a commandlet like get service, why does Windows PowerShell pick status, name, and display name? And are there any other properties? And if so, how would you go about looking at them? Well, we know how to find out if there are other properties. Just pipe those objects to get member. We get a list of can, pause, and continue, dependent services, display name. Okay, what if we want to see the display name and the dependent services? Now, the way to do that is to run the command and pipe the objects to a commandlet called select object. There's two ways to use select object. I'm going to show you the first one, which allows you to specify a comma-separated list of the properties you want to look at. So we want to look at the display name and the dependent services. So there's the information we asked for: the display name and a list of the services that the service depends on, if it has any dependencies. As you can see, plenty of services don't have a dependency. So this is how you can tell PowerShell which properties you want to look at. There's kind of a trick to this though. Let me run get service again, pipe them to get member. At the very top of this output, you can see that getService produces objects of the system.serviceProcess.serviceController type. That's the type of object. The service controller type of object always has the methods and properties you see here. In order for Windows PowerShell to create this different list of properties, it has to create a new type of object that only has a display name and a dependent services property. Any object which only has these two properties is not a service object, because a service object always has all of these properties. Let me show you what I mean. If we take getService and pipe it to getMember, we get this output. If I take getService, pipe it to selectObject, specify those two properties, and then pipe that to getMember, I can see that the pipeline no longer contains a service object. It contains a PowerShell custom object. And that PowerShell custom object has two properties, the ones that I specified, dependent services and display name. The practical upshot of this is that if you want to do something with the service as a service, maybe stop it or start it, you have to do it before it gets to selectObject. For example, if I were to do this, things might not work so well, because stop service is looking for me to input a service object, but that's not what's in the pipeline at this point. What's in the pipeline at that point is a PS custom object, because that's what was output by selectObject. So kind of the best practice for this is to make sure that selectObject is one of the last things on the pipeline. Really, the only use for a PS custom object is to create a display. So that's the last thing that should be on the pipeline when you're ready to display whatever comes out of selectObject. So that's how you can not only take a look at an object, but also just get the properties of it that you want to look at, the ones that you're concerned with for whatever task you happen to be performing. Now I said there's another way to use selectObject than there is. Let's take a look at help selectObject. Got a couple of things. We can specify a property, which is exactly what we were doing earlier. We were just leaving off the actual dash property parameter name. You can see that that parameter name is in square brackets, so the name itself is optional. You have another option to take all the properties and display them and provide a list of ones you want to exclude. So that's interesting. But here's what I want to look at now. First and last. So let's get a number of, let's say, processes. Okay, that looks to me to be about roughly 40 processes or so. Let's get those and just select, instead of selectObject, I'm going to use the alias select, the first, let's say the first 10. GetProcess still had to get all of the processes. SelectObject just discarded everything after the first 10. Now which first 10? Well, it took the first 10 that came through the pipeline. Because GetProcess is producing them in alphabetical order by process name, then that's what we see, the first 10 in alphabetical order by process name. Last would have roughly the same effect. This time I get the last 10 in alphabetical order by process name. When you don't specify a property list, when you're just using selectObject to get the first or the last 10, it does not change the type of object you're working with. If I pipe these to getMember, you can see that I'm still working with a process object. It hasn't converted it to a PS custom object. It only does that when you use selectObject to specify a subset of properties that you want to look at. Now let's try and put this together into something maybe practical. We already looked at getProcess. Now I want to sort those on virtual memory in descending order, and I want to select the first 10. So now you see a quick little list of the top 10 virtual memory consumers on the computer. And this is how these different commandlets can start to plug into one another to help you narrow down and manipulate information to get exactly the data you need to look at. Now what if you needed to maybe put this out to a file for later analysis? Well, we just plug it onto a commandlet that we learned about earlier, pipe it to out file, give it a file name, top VM users, And we can see that in the directory listing, it did create that file. And we can either open it by using type, or let's just type notepad c top vm users.txt. And there it is. So becoming familiar with these different commandlets that you can use to manipulate objects in the pipeline really allows you to narrow things down, to manipulate, to filter, to fine-tune the result set so that at some point you can come up with exactly the data you need for whatever task you're trying to accomplish. And of course, one of the biggest things you're going to want to do to narrow down and filter the result set is filter things out of the pipeline. Let's look at a really quick example. Get service. I'm going to pipe it to a command called whereObject, which we've looked at before. And in curly braces, I'm going to specify the criteria that I want to use to determine which objects get to stay in the pipeline. $_ represents the current pipeline object. I'm going to use a dot and then refer to the status and say I only want to keep those where the status is equal to running. We know that about 120 objects are going to be generated by get service. That means this script block, which is what that's called, is going to execute 120 times, once for each input object. Each time the script block executes, $_ will contain one of the objects that was piped in. It'll look at the status property, and if the status property equals running, then the object will be passed down the pipeline. If the status property does not equal running, it will be eliminated from the pipeline, so that when I hit enter, the result is that only those objects with a status of running remain in the pipeline. Of course, I could pipe those on to something else, say sort object, to sort them on name in descending order, or perhaps I might want to sort them on display name in ascending order. So you can continue to pipe these on down the pipeline until you get exactly what you want. Perhaps I want to just keep the ones that are running, sort them on name, and keep the first 10. And that's exactly what I get. Now, you do have to be just a little bit careful about the data you're looking at. Let's run getProcess as an example. GetProcess is showing working set in kilobytes and VM or virtual memory in megabytes. So 99 here doesn't mean 99 bytes. It means 99 megabytes. What we don't necessarily know is PowerShell doing some translation here, or is Windows actually storing the virtual memory utilization in megabytes? Well, I kind of doubt it. I mean, it's possible for something to use 0 megabytes, like the idle process, but pretty much everything else is using a lot of memory. You could have processes that only used a few kilobytes, though, and then keeping it in megabytes internally wouldn't make sense. Well, here's how to see exactly what it's doing under the hood. Let's look at the VM property by itself by using select object to just grab the VM property. See, obviously there's some translation going on in the normal output of getProcess, because now when I'm looking at it, this is clearly a figure that's in bytes. Let's add the name property back in. Yeah, so DNS is using 59,000, so that's 59 megabytes. If we scroll up to the original output, DNS is 57. So this is either doing some rounding, or at the very least, it's showing us a value in megabytes. Here's why that's important. If I get process, pipe it to whereObject, and say that I only want to keep those where the VM property is greater than 100, I might be a little surprised at the results. But what I've said is only show me the ones where the VM property is greater than 100 bytes, even though this column is displaying them in megabytes. So 33 megabytes is definitely bigger than 100 bytes. But if you're just looking at the digits, you might think, well, wait a minute, 33 is less than 100, so why did that show up in the list? Here's a neat little trick PowerShell lets you do. If you wanted to say 100 megabytes, just put MB on the end. PowerShell actually recognizes MB, 1 MB, 1 KB, and 1 GB, all as valid abbreviations. You can even do math with them. Show me 1 megabyte plus 1 gigabyte. So by building that into my search criteria or my filter criteria, I was able to get just the display I wanted. So it's really all a matter of making sure you know what's going on under the hood inside Windows PowerShell. Now, I want to sort of visualize what this where object commandlet is doing. So we start with a commandlet like get process. And then we pipe those objects to where object. In curly braces, we create a script block. Any script block that creates a true or a false will do. Typically, it's going to be a comparison, such as $underbar, which represents the current pipeline object, VM, greater than 100 megabytes, which is the command we just ran. So we know that getProcess on this computer is producing roughly 38 objects. That means this script block is going to run 38 times. One object at a time will be piped through the pipeline to where object. The first object will be placed into $underbar, and that allows this script block to see if $underbar.vm is greater than 100. If it's true, then that object is piped down the pipeline. If it's false, then the object is simply dropped from the pipeline and it's never seen again. Then the second object is examined. It's placed into $underbar. If the VM property is examined, if it's greater than 100, it makes it down the pipeline. If not, it leaves. Then the third object is piped in. So this happens sequentially. getProcess actually had to go and get all 38 of these objects, and then where object could look at them one at a time. Here's why that's kind of an important consideration sometimes. Let's say instead of getProcess, we were using getWMI_object. And we were retrieving, let's say, the security log events from a remote computer. That might be thousands of objects. All those are going to have to be retrieved and transmitted over the wire for us to send them to where object. And then where object is going to have to look at each one in turn for whatever comparison we've set up, go through all 100,000s of them, and keep the ones that match. If you think that might be a little time consuming, you're absolutely right. And that's something you have to be aware of with where object. If you're working with a really large collection of objects, it may take it a long time to sort through them all. If your filtering criteria is only looking for a very few number of objects out of that total, you might want to look at better ways of achieving that filtering. One of those with WMI, for example, would be to use the -filter parameter, which causes the filtering to occur on the remote machine that's generating the results. So the only thing you get back and the only thing you put into the pipeline are maybe the dozen or so objects that matched your filter criteria. If you want to then filter them a little further using where object, that's no big deal. Now, when I was first learning Windows PowerShell, this is about the point where my head started to spin. I started to look at these long commands that my book and my instructor and the websites were showing me, and I thought, how can I possibly piece all of this together? Actually, that's the clue. So let me show you sort of the workflow that I use for Windows PowerShell. Start by running one basic command. getProcess. Okay, that's not really interesting. What I'm really looking for are the most active processes on my system. I want to see the ones that are using the most resources, maybe physical memory. Alright, so I'm going to hit up arrow to recall my original command, and then just add a little to it. Let's sort it on physical memory. That's good. I mean, they're in order, and the big ones are definitely at the bottom of the list, but I kind of wanted a top 10 list, so maybe I want to reverse that sort order. Hit the up arrow, recall the command, modify it, and hit enter. Well, that's good, but I really don't need to see all these small guys. Maybe I just want to keep the top 15 or so. Hit the up arrow, add a little bit to the command, select the first 15. So that's the workflow with Windows PowerShell. Type a command, hit enter, see results. Hit the up arrow to recall that command, add to it or modify it to try and trim things down, hit enter, get results. If they're not what you want, try again. And you just keep doing that. And you can even do that with dangerous commandlets. Let's say, for example, that I really just want to keep the first 2 top users. And what I want to do is kill those. Now that is potentially dangerous. So just to make sure everything's working the way I want, I'm going to add -whatif. That lets me hit enter, see what it would have done, hit the up arrow. Oh, really? I just wanted the first one. Hit enter. Yes, that's what I wanted. Hit the up arrow, modify the command to take off the one I didn't like, and run it again. And of course, that killed Windows PowerShell since that was my top process. But that's basically the workflow that I'd like you to start thinking about. Type one command, start out small, then recall it using the up arrow. Then maybe add a little bit to it or modify it, and go slowly and piece it together one step at a time. That way you're not trying to build these really complex single line commands that stretch on for lines and lines and lines. You're starting one step at a time, taking it one piece at a time, gradually modifying and evolving what you're doing to come up with the final command that gets you what you need. In this nugget, we looked at some of the different ways to manipulate objects that are in the pipeline. We started by looking at ways to sort objects that are in the pipeline. Then we looked at ways to measure different parts of objects that are in the pipeline, and ways of selecting just a subset of the properties for whatever objects are in the pipeline. We also looked at selecting a subset of entire objects, such as the first 10 or the last 10, and at how to filter the objects in the pipeline so that we just have the ones we want at the end of the pipeline. Finally, we looked at a good way of working with Windows PowerShell, a workflow that involves typing a command, hitting enter, seeing the results, recalling that command, modifying it, hitting enter, seeing the results, and repeating until you get exactly the results you want. I hope this has been informative for you, and I'd like to thank you for viewing.